Good day. View. Me alone.
all over the world. Today, we want to discuss about sequence and series, or you might try to call it series and sequence. So that is the topic that we want to discuss today. So what is sequence and what is series? A sequence is any set of numbers generated in accordance with a definite pattern. A sequence is any set of numbers generated in accordance with a definite pattern. A series is any set of numbers generated in accordance with a definite pattern. So accordance with a definite pattern. There is common difference between 1 and 3. The difference is 2. Between 3 and 5, the difference is 2. Between 5 and 7, the difference is 2. So if you have a set of number arranged in accordance with a particular pattern, with a definite pattern, such arrangement is referred to as a sequence. And in this case now, this sequence is a linear sequence. What a plus common difference. In this case, the first time is 1. Then the second time, how do we get this 3? The second time, that will be 1 plus 2, and that is equal to 3. Then the third time in this sequence, how many common difference do we have there? 2. 1, 2. So that will be a plus 2d. That is 1 plus 2 times 2. 2 into bracket 2. So 2 times 2 is 4. 4 plus 1 is 5. You realize that we can, if we continue in this order, we can actually generate the last term, which is called the nth term of this sequence. And if we do that, we are going to have c raised to power n, which is equal to a plus, look at, when we have 2 here, the coefficient of d here is 1. When we have 3, the coefficient of d is 2. Then when we have n, the coefficient of n will be n, d will be n minus 1 into bracket d. And that's what we are going to have. Then in this case now, the first time is 1 and plus into bracket n minus 1. The common difference is 2. We can open up to get 1 plus 2n minus 2. Then at the end of the day, we are going to get 2n minus 1, which will be the nth term of this particular sequence. So the example of a sequence that we have on the board is called a linear sequence or arithmetic projection. So when we have this type of sequence, how do we generate the next term or the nth term? We generate the next term by adding the common difference to the one that precedes the first term. And as we have it on the board, if this first term is 1, and we know that the common difference is 2, then for me to get the next term, it will be 2 plus the term, that is 3. For me to get this one, it will be 2 plus 3, 5. Then to get another, the fourth term is 7. If I want to get the fifth term now, it will be 7 plus 2, that will be 9. Then if I want to get the nth term, the last term, referred to as the last term or the nth term, then it will be by in the nth term by formula, Tn in this particular sequence is given as 2n minus 1, and that's what I'm going to get. If this is 4 now, if this is 4, if what I have here is 4, then what will be the fourth term? The fourth term, that will be 4. 2 times 4, 8. 8 minus 1, 7. That is 7. If this is 5, that will be 2 times 5, 10 minus 1, 9. So the fifth term will be 9. So that's how to generate this type of sequence. Then generally, there are two types of sequence. We have the linear sequence, which is otherwise known as arithmetic progression, and we also have the one that is called the exponential sequence. An exponential sequence is otherwise known as geometric progression. And of course, we are familiar with this arithmetic progression and geometric progression at the elementary, at the elementary, at the secondary school stage. So this given example is example of a linear sequence or arithmetic progression. In this case, we have we denote A as the first term and D as the common difference. So under arithmetic progression, we deal with addition and subtraction. If I want to know the next term, I will keep adding, and if I want to know the common difference, I will subtract the second from the first, or the third from the second, and in that order. So linear sequence has to do with addition and subtraction. Then another type of sequence that we can get is what is called the geometric progression. In case of geometric progression, we can have something like 1, 2, 4, 8, dot dot dot. In this case now, let's look at this pattern. It's also in a particular pattern, because the difference between oh, the difference here now. Look at this now. The first time also we denote it as A, but in this case now, we don't talk about the common difference. We talk about the common ratio, because this sequence is an exponential sequence. So how do I get the second term? In this case now, we denote the common ratio as R. In this case now, our R is equal to 2. How do we get that 2? The 2, that simply means that this first term, T1, this is T1 first term, this is T2 second term, third term, fourth term. How do I get the common ratio? That will be T2 divided by T1. That is 2 divided by 1. That is 2. Or I can say R is equal to T3 divided by T2. And that is going to be 4 all over 2, and so to 2. So this sequence also follow a particular pattern. In this case now, if I want to get the next term, I will multiply. I'm going to multiply by the common difference. If I want to get, like, I have the fourth term as 8. If I want to get the fifth term, that will be 8 times 2. That will be 16. Then if I want to get the common ratio, I will divide. So in this type of sequence, which is called exponential sequence or geometric progression, it has to do with multiplication and division. That is the difference between a linear sequence and an exponential sequence. So I would love to treat this sequence separately. The first one, arithmetic, arithmetic progression. Arithmetic progression. Arithmetic progression is otherwise known as the common difference. In arithmetic progression, let's say this is T1, T2, T3, dot dot dot, up to Tn, the last term. This is Tn. So the first term is denoted as A. So the second term will now be equal to then the common difference is equal to T2 minus T1, or T3 minus T2, or in that order. The first term is denoted as A, which is T1. How do I get the second term? The second term will be A plus D, the common difference. From the example that I gave, Okay. So that is the formula to find the last term or n term of an arithmetic progression, that is Tn is equal to a plus n minus 1 into bracket v. This is the formula. So let's take example. Let's say example 1. Example 1. Find the a the 8th term, b the 15th term of an arithmetic progression given as 12, 7, 2, dot dot dot. In this case now, in this case now, what is the formula? We first write out the formula. In this case now, we have 12, 7, 2, dot dot dot. The first time in this case is 12. The common difference is equal to the second time, 7 minus 12, and that is equal to minus 5. That is what we are going to get in this case now. So the formula for n term Tn is equal to a plus n minus 1 into bracket v. Then the 8th term now, T8, will now be what? A plus 8 minus 1 into bracket v, and that will be a plus 7d. That will be a plus 7d. So if that is what we are given, then the 8th term T8 will now be what? In this question now, a is equal to 12. So we say 12 plus 7 multiplied by d is equal to minus 5, multiplied by minus 5. Then we are going to have 12. 7 times 5, that's minus 35. So in this case, we are going to get the 8th term to be minus 23. So T8 is equal to minus 23. That's the 8th term. Then we are also we are asked to find the 15th term. T15, the 15th term will be what? A plus, from if we apply the first formula, a plus 15 minus 1d, and that will be a plus 14d. So a is given as 12 plus 14 into bracket, then d is minus 5. So we are going to get 12 minus times plus times minus is minus, then 70, that will be minus 58. So the 8th term is minus 23, while the 15th term is minus 58. So we take another example. Let's take another example before I go to exponential sequence or geometric progression. Let's take another example, example 2. In this case now, we are given that the 5th and 10th, we are given that the 5th and the 10th terms of an arithmetic progression are minus 12 and minus 27 respectively. So the question now says find the AP, the arithmetic progression, and its 15th term. So in this case now, this is what we are given. Solution. We are given the 5th by formula. Tn, the nth term, is given as a plus n minus 1 into bracket d. So T5, which is the 5th term, will be a plus 4d, and is given as minus 12, equation 1. Then the T10, which is the 10th term, is given as a plus 9d, and that's given as what? Minus 27, equation 2. So there are two equations here and two variables, a and d. So we are going to solve this simultaneously. So I can say equation 2 minus equation 1. If I do that, I'm going to get 5d to be equal to minus 27, that's minus 15. Then divide both sides by 5. So d will be equal to minus 3. So d will be equal to minus 3. And from there, I can substitute. I can substitute d is equal to minus 3 into equation 1. And if I do that, equation 1 is a plus 4d equal to minus 12. So a will now be equal to a plus 4 into bracket minus 12 minus 3 is equal to minus 12. From there now, I'm going to get a minus 12 is equal to minus 12. So a is equal to minus 12 plus 12. So a is equal to 0. So in this case now, our a is equal to 0 and d is equal to minus 3. So we have to find the AP. How do we get the AP? The AP, that is the arithmetic progression or linear sequence, is given as the first term is 0, when you had, this might this the second term will be first term plus second term, that will be minus 3. The third term you keep adding, that's minus 3, and that's minus 6 minus 9 dot dot dot. So the question now says that we should find the 15th term, T15. T15 will be A plus 14D from the formula to find the nth term of an arithmetic progression. Then here I'm going to get 0 plus 14 into bracket minus 3. That is 0 minus 42. Then the T15 will now be minus 42. So the 15th term in this case is given as minus 42. So it's given as minus 42. So that is that about the nth term of an arithmetic progression. And there's what we call arithmetic mean. That is, if you are given three consecutive term of an AP, how do we find the arithmetic mean? Arithmetic mean. Arithmetic mean. Let's say we are given three consecutive terms of an AP as X, Y, and Z. So how do we find the arithmetic mean? Of course, there are three terms there, X, Y, Z. Y, X and Y. So Y is the mid number. Then that simply means that if you find the common difference here, the common difference will either be Y minus X, which is equal to the same thing as Z minus Y. In this case now, this is the common difference. Is either Y minus X or Z minus Y. We can collect the terms. We have Y plus Y will now be equal to X can come to the other side, X plus Z. So 2Y is equal to X plus Z. Divide both sides by 2. So Y is equal to X plus Z all over 2. So if you are given three consecutive terms of an AP, then if you have to find the arithmetic mean, this is the formula that you apply. Y is equal to X plus Z divided by 2. Let's just give one example on this before I move to geometric progression or exponential sequence. Let's give example on this. For instance, if you have X minus 2, X plus 2, X plus 3, and 2X squared plus 1 are 3. They are three consecutive. There are three consecutive terms of an AP. There are three consecutive terms of an AP. Find the possible value or values of X. So in this case now, solution. The first one is X plus 2, followed by X plus 3, then 2X squared plus 1. These are three consecutive terms of an AP. Then call this first one X, Y, and Z. For us to be able to find the possible values of X, this is what we do. From that formula, we know that Y is equal to X plus Z all over 2. When you have three consecutive, which is called the arithmetic mean. Then in this case, X plus 3, which is Y, is equal to X plus 2 plus 2X squared plus 1, everything divided by 2. Everything divided by 2. So we can cross multiply so that we have 2x squared plus x plus 3 to be equal to 2 into bracket x plus 3. So here we have 2x squared plus x plus 3 to be equal to 2x plus 6. So we can bring everything to the left hand side. So we have 2x squared plus x minus 2x plus 3 minus 6 equal to 0. So 2x squared minus x minus 3 equal to 0. And that is a quadratic equation. So of course, we can factorize this to have 2x squared minus 3x plus 2x minus 3 equal to 0. Let's do the grouping. If we do the grouping there, then what do we get? So x is common in the first bracket. So I'm going to have x into 2x minus 3. Then plus 1 is common in the second one, 2x minus 3 equal to 0. So here I'm going to have x plus 1, then 2x plus minus 3 equal to 0. So x plus 1 equals 0 or 2x minus 3 equal to 0. X is equal to minus 1 or 2x is equal to 3. Therefore, x is equal to minus 1 or 3 all over 2. So with the knowledge of arithmetic mean, we are able to solve this particular problem. So From there now, I'll move to geometric progression and get the general formula to find the nth term or last term of a geometric progression. Geometric, geometric progression. So geometric progression is otherwise known as exponential sequence. Then the general form is given as AR, because for us to know the next term, we keep multiplying by the common ratio. Then we have AR squared, AR cube, dot, dot, dot. So under geometric progression, the first term, T1, under geometric progression, let me write it here. Under geometric progression, the first term, T1, is given as A. The second term, T2, is given as AR. The third term, T3, is given as AR squared. Then if you follow in that progression, then Tn will now become what? AR into bracket n minus 1. Because when the subscript here is 3, the power is 2. So when the subscript is now n, the power will be n minus 1, because it's reduced by it reduces by 1. So this is the nth term or less term of a geometric progression. So that is the formula to find the nth term or last term of a geometric progression. Of course, we've given the formula to find the nth term or last term of an arithmetic progression. In this case now, it is an exponential sequence. Then this is the formula to find the last term or nth term of a geometric progression. So let's take one example under this. So let's take one example under this. Say example 4. So we are given that the third and seventh terms of a geometric progression are 81 and 16 respectively. 81 and 16 respectively. Find the first and fifth terms. Solution. So in this case now, Tn, which is the nth term, is given as AR raised power n minus 1. So the third, T3, will be what? AR raised power 2. Is given as, the third is given as 81, equation 1. While the seventh, T7, will be equal to AR raised power 6, is given as what? 16, equation 2. So the question says we should find the first and the fifth term. Of course, if you're able to find A here, that's the first, then we find the fifth term. There are two equations. What can we do here? There are two equations and two variables. So let's just say equation 1 divided by equation 2, because we have AR squared divided by AR6 raised by 6 is equal to 81 divided by 16. A can take care of A. In this case now, A can take care of A. Then here we are going to have R raised by 2 minus 6 indices. That's law of indices. Then that will be minus, then we can write this 81 as index of 4, 16 as index of 2. Then I'm going to have R raised by minus 4 to be equal to 3 all over 4, everything raised by 4, and 3 all over 2, everything raised to power 4. Then what do we get from there? What do we get from there? From our knowledge of indices, I can get R raised by 4, R raised by minus 4 to be equal to, if I want this raised by 4 at the right hand side to attract the negative, I will interchange. I would bring the numerator to the denominator and vice versa. So this same thing as you say 2 all over 3, everything raised by minus 4. In this case now, the power are equal. We equate the base. Therefore, R is equal to 2 all over 3. So we apply the knowledge of indices here to be able to solve that. So we know R. Then we now say substitute R is equal to 2 over 3 into equation 1. What is equation 1? AR squared is equal to 81. Then here we have A multiplied by 2 all over 3 squared is equal to 81. So we have A 4A all over 9 is equal to 81. When we cross multiply, we are going to get 4A to be equal to 81 times 81 times 9, that's 729 all over 4. And that's A is equal to 729 all over 4. And that is the first time that we are asked to find. And we are asked to find the first term. We have to find the first term and the fifth term. So in this case now, the fifth term, T5, will be equal to what? A r raised power 4. What is A? 729 all over 4 multiplied by R is 2 all over 3. Everything raised to power 4. Then here I'm going to have 729 all over 4 multiplied by 16 all over 81. So here I'm going to have 81 here 1, 81 here 9, 4 here 1, 4 here 4. I'm going to have 9 times 4. So the fifth term, T5, is equal to 36. And that is what we are going to get. That is what we are going to get. So we take one more example on this, and I'll go to geometric mean. We take one more example on this, and I will introduce geometric mean. So in this case now, so you can just check standard textbooks and look for further examples on both arithmetic and geometric sequence. So just visit the good textbooks and look for further examples. Then apart from arithmetic, we also have geometric. We also have geometric mean. That is, if we have 3 consecutive numbers, x, y, and z, and these numbers are exponential sequence, they are being arranged in exponential sense, x, y, z, then how do we get the geometric mean? Of course, here we talk about common ratio, r. Under the arithmetic mean, we talk about common difference. Here now we are going to have y all over z to be equal to z all over y, because the common ratio here will be second term divided by first term, or third term divided by second term. So if we must cross multiply here, we have y squared to be equal to y all over x is equal to xz. Then if I take the square root of both sides, y in this case will now be square root of xz. So this is the formula to find the geometric mean. This is the formula to find the geometric mean. So let's take note that this is the formula to find the geometric mean. Then we take one example under this. We are going to take one example under geometric mean. Then we move to series. So example 5. Example 5. The question says insert two geometric. Insert two geometric means between 12 and 324. So that is what we are asked to find. So we have to insert two geometric mean between 12 and 24. Let's say this is 12. Then let the two numbers be x and y. Then this 324. So what do we do? What do we do? Let the two numbers be x and y. So what do we do here? So in this case now, what is the first term? T1 is equal to 12. That's the first term. T1 is equal to A and is equal to 12. That's the first term. Then what is the fourth term? T4. T4 is equal to AR cube and it's equal to 324. That's what we are going to get. It's equal to 324. That is what we are going to get. So from here now, what is A? T1 is 12. So here I'm going to change this A to 12. 12R cube is equal to 324. 12R cube is equal to 324. I'll divide everything by 12. 12 will cancel 12. Then I'm going to have R cube to be equal to 12 divided by 324. Here is 2. 2 is this 24. 24. Then 12 in 24, that's 10. 12 in this, I'm going to have 27. Then R cube is equal to 3 raised to power 3. The power are equal, we equate the base. Therefore, R is equal to 3. If R is equal to 3, then X, our X is what? The second time, T2, is given as AR. That is, A is what? A is 12. That is 12 multiplied by 3, and that will be 36. Then Y is the third term, T3. Then that's AR squared. And we are going to have 12 multiplied by 3 square. Then 3 square is 9. 9 times 12 is equal to 108. So T3 is 108. and T2 is equal to 12. So that is what we are going to get. That's what we are going to get. So we can look for further examples if we consult standard textbook. So that is that about sequence. I will now introduce series. I will introduce series. The summary of sequence is that a sequence is the arrangement of number in a given pattern. That is, the pattern must be unique. If that sequence is arithmetic sequence, then we must have a common difference. And if it is geometric, we must have a common ratio. So let's talk briefly about series. Series. So what is series? What is series? A series is formed by the sum of terms of a sequence. That is, when we talk about series, series simply means when we add all the terms that we have in a sequence together, then it is called series. That is just the meaning of series. If you have a particular pattern, a sequence, if we add all the sum of a sequence together, we get a series. So series has to do with sum of all the sequence, all the terms that we have in a sequence. That is what we call series. For instance, in an AP, in an AP where we have A, in an AP we have A, the first term as T1. In an AP where we have A plus D, this is T1, the first term. The second term, A plus 2D, this is the third term, plus dot dot dot. So if we had all the terms that we have in this sequence together, we are going to get what is called a series. So sequence is the addition of all the terms that we have. Series is the addition of all the terms that we have in a sequence. So for an AP, so we can say sum of an AP. That is, if you have a linear sequence, what is the sum of everything together? Then the sum by formula, the sum of an AP is given as n all over 2 into brackets 2a plus n minus 1 d. That is what we are going to have. So if you want to find the sum of an AP, it's given by what you have on the board. But you recall that our last term or n term is given as a plus n minus 1 into bracket d. That is, when we have this a that we have here now, if we split the a into 2, a plus n minus 1 into bracket d, everything here, it is called the nth term or the last term. So we can also say that the sum of an AP can be given as n all over 2 into bracket a plus l. Still the same thing. So depending on the nature of the question, if you are given a question and you are given the nth term, you are given the first term and common difference, then go ahead and use this first formula. But in a situation whereby you are given the first and the last term, and you are required to find the number of terms in that sequence, then you can apply the second formula. But the two formulas is actually the same thing. The two formula is actually the same thing. So please note that to find the sum of an AP is either use the formula, the first formula, or the second formula. So let's take examples. Let's take example. So for an AP, for an arithmetic progression, A is equal to 25, D is equal to minus 3. Find the value of n if Sn is equal to 112. So in this case now we want to find the number of terms that we have if the sum of that AP is given as 112. Solution. So the first time is given as 25. The common difference here is negative. A is equal to 25. D is equal to minus 3. Then the sum is given as 112. So we are required to find n, the number of terms that we have in that AP. By formula, x is equal to n all over 2 into bracket 2a plus n minus 1 d. That is the formula. So we are given the sum as 112. which is equal to n all over 2. We want to find the number of terms that we have in that arithmetic progression. Then 2 multiplied by 25 plus n minus 1 into bracket minus 3. So we have to be very careful there. Here will be n all over 2 into bracket 2 times 25, that's 50. Then 50 minus 3 times n, that's minus 3n, minus that's plus 3. So here we are going to have n all over 2 into bracket 53 minus 3n. That's what we get. 53 minus 3n. So if we, from here now we can cross multiply 1, 1, 2. So if we cross multiply here, if we do cross multiplication there, if we do cross multiplication, then we are going to have n into bracket 53 minus 3n is equal to 224. Then here, if I open up, I'm going to get 53n minus 3n squared to be equal to 224. Then I can collect the like times. I can bring everything to the right hand side so that I'm going to have 3n squared minus 53n plus 224 equals 0. Then if that is what I'm going to get, then I can factorize this. And if I don't want to stress myself, I can use completing the square method or the formula method. But of course, I can factorize this. So if I use 3, if I use 3 to multiply 224, multiply by 3, that's 3 times 4, 12. This is 7, 3 times 6, 7, then 3 times 2, 6, 7, 4. 3 times 4, 12. 3 times 4 is 12. I could 1. 3 times 3, that's 6 plus 1, 7. Then 6 to 7. What are the two factors that will give you minus 53? Then that will be minus 21 minus 32. I'm going to have 3n squared minus 21 minus 32 n plus 224 equal to 0. You can check it out. Then what is common here? 3n. I'm going to have n minus 7. Then what is common here? In this other bracket is minus 32. Then we are going to have n minus 7 equal to 0. So that we are going to have 3n minus 32, then n minus 7 equals 0. So we have 3n minus 32 equals 0, or n minus 7 equals 0. Here we have 3n is equal to 32, or n is equal to 7. Therefore, n is equal to 32 all over 3, or 7. And of course, in this case now, we are going to choose, because we are talking about number of terms, we are going to choose n equal to 7, because we cannot have 10 point something terms. So terms can only be whole number. So that's what we are going to have. So you can consult standard textbook. We have so many examples there that we can actually apply. So that is what we are given. Then probably let me take one more example before I go to geometric progression, the sum of GP. So let's take one more example under sum of AP. Then I will take sum of GP. So another example, say example 7. So in this case now, we are given that the sum of the first four terms of an AP is 26, and that of the next four terms is 74. So the question now says find the values of the first question, A, the first term. Then the second question, the common difference. So in this case now, we are going to list what we are given. So the question says that the sum of the first four, that is, sum of the first four, S4, will not be equal to n all over 4. Of course, we know that sum by formula is Sn is equal to n all over 2 into bracket 2a plus n minus 1 into bracket d. That is the formula. So in this case now, when n equal to 4, the first 4 will be 4 all over 2 into bracket 2a plus n minus 1, that's 4 minus 1, 3d. 3D is equal to 26. That is what we are given. Then from there, 2 here 1, 2 here 2. We can have this 2 here 1, 2 here 2. Okay. Then we can have it to be 2 into bracket 2a plus 3d is equal to 26. 2 can still divide everything. So that at the end of the year will be 13. So at the end of the year, we have 2a plus 3d is equal to 13. I can call that equation 1. So that's what I'm going to get. I can call it equation 1. That's what I will get. That is the first part of the question. Then the second part of the question now says that then the sum from the fourth. So the second part of the question says that and that of the next 4. This is the first 4. Then from S8 to S4 now, the next 4 is given as 74. That is, our half has to be X8 minus X4 to be equal to 74. Then what do I have here? S8 will be 8 all over 2 into bracket 2a plus, that will be 7d, minus 4 all over 2 into bracket 2a plus 3d is equal to 74. That's how we interpret that. The next 4, this first sum of the first 4, we have gotten that in equation 1. Then sum of the next 4, that is from S4, S8 to S4. So here, what do we have here? 8 will reduce this to 4. I'm going to have 4 into bracket 2a plus 7d to be equal to minus here 1, here 2. 2 into bracket 2a plus 3d is equal to 74. Then if I open up here, I'm going to get 8a plus 4 times 7, 4 times 7 is 28d minus 4a minus will control everything here, minus 6d is equal to 74. So that here I'm going to have 4a minus 22d is equal to 74. And of course, we can divide through by 2. So that we are going to equation 2. So what is equation 1? We have equation 1. We derive equation 1 to be 2a plus 3d to be equal to 13, equation 1. So in this case now, we have two equations. We have two equations with two variables. So we can solve this simultaneously. Then what can we do here? If we subtract equation 2 from equation 1, then what do we get? Here we are going to have, is this 11? 8? No, here is plus. So we say equation 2 minus equation 1. If we do that, 2a minus 2a will cancel out. Then I have 8 minus 3, 11 minus 3, that's 8d, will be equal to 37 minus this is 24. Divide both sides by 8. Therefore, d is equal to 3. So the common difference is equal to 3 from what we have there. The common difference is equal to 3. We now substitute d is equal to 3 into equation 1. What is equation 1? 2a plus 3d is equal to 13. We have 2a plus 3 multiplied by 3 is equal to 13. So 2a plus 9 is equal to 13. So 2a is equal to 13 minus 9. Then from there we have 2a is equal to 4. Then a is equal to 4 divided by 2. So a is equal to 2. Therefore, d is equal to 3 and a is equal to 4, is equal to 2. And that is what we are asked to find. So that's what we are asked to find. So the last concept that we discussed for today is the sum of geometric progression. The sum of geometric progression. So in case of geometric progression, the sum of geometric progression. So sum of geometric progression. In this case now, there are 3 formulas that we use under the sum of geometric progression. The first one, depending on the value of r, the first one is that if our common ratio is greater than 1, if the common ratio is greater than 1, then the sum will be given as a into bracket r raised power n minus 1 all over r minus 1. The second formula that we have is that if r is less than 1, then the sum of GP will be what? A into bracket 1 minus r raised power n all over 1 minus r. Please, let's take note. Then if the sum, if you have sum to infinity, if the sum to infinity, then the sum to infinity is given as a all over 1 minus r. So these are the three formulas that we use under sum of GP. So the sum of geometric progression depends on the value of r and if it is sum to infinity or not. So whenever the common ratio is greater than 1, the sum is given as a into bracket r raised by n minus 1 all over r minus 1. So if r is less than 1, then we reverse the formula, that is from r raised by n minus 1 to 1 minus r raised by n. Then if it is sum to infinity, then this is what we have. We have sum to infinity to be a all over 1 minus r. So these are the three formulas that we have under the sum of an exponential sequence, which is geometric progression. So let's just take one or two examples under this. So the first example, the third term of a GP, geometric progression, is 63. And the fifth term is 567. Find the sum of the first six terms of the progression. So in this case now, what are we given? We are given the third. Of course, the formula for n term of GP is a raised by n minus 1. This is the formula for n term. So if we are given the third, that's T3, it will be a r raised by 2. Is given as 63, equation 1. And we are given the fifth, T5, is given as a raised by 5. A raised by 4 is given as what? 567, equation 2. So we have two equations with two variables. Of course, we know what to do. We can actually solve this simultaneously. We can say equation 2 divided by equation 1, and that will be ar raised by 4 divided by ar squared is equal to 567 divided by 63. A can cancel a, then we have r raised by 4 minus 2, law of indices. Then 63 minus 567 is 9. So r squared will be equal to what? 3 squared. In this case now, the power are equal, then we equate the base, and it's vice versa. So therefore, r is equal to 3. So if you know the value of r, then we now substitute r equal to 3 into equation 1. What is equation 1? Equation 1 is ar squared is equal to 63. So a3 squared is equal to 63. Then 9a is equal to 63. We divide both sides by 9. So a is equal to 7. So we have gotten the value of a to be equal to 7 and r to be equal to 3. So the question says that we should find the sum of the first 6, that is when n is equal to 6. So in this case now, r is greater than 1, r is equal to 3, which is greater than 1. So the formula for the sum that we are going to use, sum in this case will now be a into bracket r raised to power n minus 1 all over r minus 1. Why do we apply this formula? Because the value of r is greater than 1. If the value of r is less than 1, then we go ahead and use the second formula. So yeah, the value of a is 7 into bracket r is 3. We have 3 raised to power 6. We want to find the sum of the first 6 when n equal to 6, minus 1 all over 3 minus 1. Here I'm going to have 7 into bracket. I will have 7 into bracket 3 in 6 places is going to give us 729 minus 1 all over 2. Then I'm going to have 7 multiplied by 728 all over 2. So if we find that, then at the end of the day, I'm going to have 7 multiplied by 364. So that is same thing as 2,548. So the sum of the first six terms of this GP is 2,548. Then let me just give the last example for today. That is under sum to infinity. As I've said earlier on, in this case now, our R is greater than 3. That's why we apply this formula. You can come across another question in which the value of R will be less than 1. Then you go ahead and apply the second formula when R is less than 1. So I will give the last example for today, and that is under sum to infinity. So example, say 9. Say find the sum to infinity. Find the sum to infinity of the series 1 plus 1 all over 3 plus 1 all over 9 plus 1 all over 27 plus dot dot dot. So in this case now, of course, we know the formula when we have sum to infinity. So the formula in this case now, A is equal to 1. Then what is the common ratio? Common ratio will be second term divided by first term. So that will be T2 divided by T1. T2 is 1 all over 3 divided by 1 is still the same thing as 1 all over 3. So R is equal to 1 all over 3. That is R. So the sum to infinity now is given as A all over 1 minus R. What is A? A is 1 all over 1 minus 1 all over 3. So here we are going to have 1 all over 1 minus 1 over 3 will be 2 over 3. That will be 2 over 3. Then the sum to infinity will now be 3 all over 2, which is same thing as 1 over 1.5. So this is the sum to infinity. So I would love to stop here. But if you have any questions under sequence and series or series and sequence, you can just type it in the comment section. I promise to do justice to whatever question that will be sent via the comment section. So I would love to stop here. But before I stop, I just want to do the recap of all what we have discussed. The first one is that we start from the linear sequence. And we said that linear sequence or arithmetic progression has what is called common difference and first term. That is, in the linear sequence, we talk about common difference. And the last term of the linear sequence or n term is given as A plus n minus 1 into bracket D. So that is what we talk about linear sequence. Then geometric sequence or exponential sequence, we said the last term or the nth term is given as A into bracket R raised by n minus 1. In a linear sequence, we have common difference, but in an exponential sequence, we have common ratio. We also talk about the sum of a linear sequence. Under the sum of a linear sequence, we said sum is equal to n all over 2 into bracket 2a plus n minus 1 d, or n all over 2 into bracket a plus l. Then under the sum of geometric progression, we give the sum as a into bracket r raised by n minus 1 r raised by 1 when r is greater than 1. We also said the sum can also be equal to a into bracket 1 minus r raised by n all over 1 minus r when r is less than 1. Then we give the sum to infinity to be a all over 1 minus r. So this is the recap. This is the summary of what we discussed today. So I'd love to stop here. Thank you for listening.